Alright, today we're going to talk about the different rules for taking the derivative. Different rules for differentiation. Okay, we're going to talk about the different rules. Now, the nice thing about this is these actually are shortcuts to taking the derivative of something. So you actually don't need to take the derivative of a function using the definition each time. So the limit as h approaches 0 of f of x plus h minus f of x over h. You don't need to do that each time. There are shortcuts that I'm going to show you. Alright, cool. The first one is the derivative of a constant, the derivative of a number. What is the derivative again?
The slope at a certain point.
Okay, slope of a line, or slope of a curve or graph at a certain point. Okay, so to take the derivative of a number, of a constant, is just 0. So let's say f of x is equal to 2. The derivative of 2 is 0. And that's it. Any constant. The derivative of any constant is always going to be 0. What? The derivative of any constant is always 0. So what's the derivative of 2? 0. What's the derivative of 5? 0. So go ahead and write the derivative of 123. Yeah, I know it's hard.
I'm gonna take a guess.
Hard to do. Oh, thanks.
That's cool. Almost as close.
Cookies in a second. Huh? Yeah. Why?
Yeah, it's that shirt. That's what's doing it.
Please don't. What's that?
I know, that must be it.
Rating.
Okay, and we got 0? What's wrong with you guys? Okay. So the constant, derivative of a constant or whatever, that's easy. It's always 0. The power rule is a little more complicated, but it's really not that complicated. It's a little more, but a little more complicated than simple is still relatively simple. Okay, so the derivative of something that has a power. So let's say x squared, or x to the third, or something like that. You take the power, you move it down to the front, and then you subtract 1 from it. For example, let's say you have x squared. You take the square, you take the 2, and you move it down in front of the function, and then you subtract 1 from it. 2 minus 1 is 1, so then the derivative of x squared is 2x. So you take the power, you move down out front, you take 1 less than whatever power it was. That's called the power rule. You don't switch it, you move it down, whatever's left. Okay, go ahead and try this one. Okay, so again, you take this 2, you move it out front, you gotta multiply with that 3. So the derivative of 3x squared is 6x. Any questions there? You do. 2 minus 1 is 1, so that's just x. X to the power of 1 is just x.
Oh.
Yeah? Okay. Anyone still copy this? Okay, the sum and difference rule. So I'm going to show you 3 rules and we'll look at an example. So if you're taking the derivative of, something plus something else, it's really just the derivative of u plus the derivative of v, or minus, whatever it is. And this one looks more complicated than it is. Just like the limit part looks more complicated, like the limit of each term, but you were going to do that naturally anyway. So this one, all you do is, if you want to take the derivative of this, you take the derivative of x squared, and then you take the derivative of 2x. Okay, so what's the derivative of x squared?
2x.
2x. Everyone okay with that? You take the power, you move it down. That's 2x, and then that's 1 up here. What's the derivative of 2x though?
1. No, 2.
What's the power up here? 1. You bring it down, so 2 times 1 is still 2. What's the power left now? 0. X to the power of 0 is 1, so you get 2. So the derivative of x squared plus 2x is 2x plus 2. Any questions there? Yeah.
What was for the 3x squared?
The derivative of that is 6x. You just take the 2, bring it down, you multiply with the 3. And then you have 6, and then x.
So if it would have been like 3x cubed, it would have been 3x squared?
If it was 3x cubed, it would be 9x squared.
9x squared?
Yeah, because you take the 3, multiply it with those. Okay, go ahead and tell me what the derivative of that is. Okay, so you take this 3, you move it out front, you multiply with the 2, so you get 6x, and then 1 less than 3 is 2. Minus, you take the 2, you move it out front, so you get 2x, and 1 minus 2, or 2 minus 1 is 1. So this is your derivative.
Oh, that's great. That's fantastic.
Alright, any questions there? So, if we were to use the definition, the limit as h approaches 0 of f of x plus h minus f of x over h. If we plug that in here, eventually will we get this?
Yes.
Yes. Okay, so this is doing the same thing, but a lot shorter. Okay, so this is the shortcut to all that. So you can always take the derivative using the definition. So you can always plug it into that equation, or the limit, multiply everything out and simplify, you get the same answer. But this is just way shorter. Okay, any questions here? Yes? 2x plus 2. What's the power right now? 1, right? And the 2 times 1 is still 2. But now, this is x to the power of 0, which is 1. So that's why it's not there anymore. Alright, any other questions with this? Okay, so now that we talked about those 3 properties, the constant, power rule, and sum and difference rule, we're going to look at an example where we got to use multiple rules at once. So we're going to find, what does that mean again? The derivative. We're going to find the derivative of this function right here. So go ahead and copy that down. Okay, so what we're going to do is, this is the function again. You don't need to copy down again. But all we got to do is take the derivative of each term. So we're kind of taking the derivative 4 different times. Rid of the first term, second term, third term, and fourth term. What's the derivative of x cubed? 3x squared. Bring the 3 down. 1 less than the original power, so 3x squared. What's the derivative of 6x squared? 12x. What's the derivative of negative 5/3 x?
Negative 5/3.
Negative 5/3. So if it's just an x, if it's just a variable, and you're taking a derivative with it, it's just the number itself. And what's the derivative of 16?
0.
That's your derivative.
Wait, so the 16 drops?
Yeah, because the derivative of a constant is 0.
It'd be funny on the AP exam, so you use the definition for all your derivatives.
No, you wouldn't fail. I mean, you probably run out of time.
Yeah, that'd be funny.
But I mean, you could
That'd be sad.
use the definition which is derivative problem.
That would suck. Like x to the power 3, like, oh, that's
Alright, any questions?